proportional to the current flowing through it and temperature physical conditions. Yeah. Is it right?
Wait, what? Repeat.
Ah,
Well
cha.
done, Sam. Are you proud?
Sam, are
Wait.
you happy?
You said
Voltage
the input wrong.
across a conductor is directly proportional to the current flowing through it. Something,
Okay.
temperature, physical conditions.
Something. It's something.
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 Aye.
Aye,
It's.
Baba, Mr. Gulp, be strong.
Yes, Sam. Yeah. You're gonna write something in the test.
Something in the test.
Aye, I'll be strong, Shemai. There's no ways.
You're gonna
He
go over,
subtract.
but don't lie.
No, he won't
Don't
be strong because he subtracted a mark from me, not including stuff for no reason. Right. So
But am I right?
you partially correct.
Yeah, partially, not
What?
100%.
Right.
Let's
So
pray out of three. Let's
so
pray out of three.
it's it's across, right? Okay, let me redo this rather. Let me say it properly, unlike Sam.
Bro,
Right.
one word. One word.
Current. Right. Okay. Let me word it like this rather. The voltage across 2 points in a circuit is directly proportional.
Yo, Big P, is this
Yes.
explaining what Ohm's law is?
Yes.
Ah, yeah, yeah.
That's the first point. That's one mark out of three. Right. Then the second point is the resistance is indirectly proportional to the current. It's the resistance of a conductor, but this is the more summarized version.
Wait, so if we say the definition that we're given in the textbook, we get all the marks.
If you so this isn't the complete definition.
Like I'm saying, if we say the one Sam said, but properly, then we'll
And
get all the
Yeah.
marks.
complete, yes, then yes,
Like
you
just
should get.
add temperature remains
Right?
constant.
No, provided,
Or given all
Physical
yes.
physical
conditions.
conditions remain constant,
Bro, I missed
including
one
temperature.
word. Aye.
You missed more than one
No,
word.
you missed this whole block, Sam. You didn't say anything about resistance.
I, s- I said that in
Ah,
the
listen,
June
No,
exam.
no, 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 no,
eh,
no,
Baba,
no, no.
upare,
Hey,
upare. Sam, you didn't
aye.
say
So
anything about resistance.
it's like,
Yo, guys, now that I think about it, bro. Wow, last exam for robotics. I excited, bro.
all those notes, yo, I'm throwing them away.
I'm gonna burn them
Incompleted
fast.
I already
activities.
lost them. Yeah. I don't even
Incompleted
have them.
activities.
We never did
I'm
any of
starting
those
a whole cry,
activities.
yo, burning those papers.
Throwing them all in the dustbin.
In
I
fact,
very
no,
you.
no,
My
They were
that
so
dustbin.
they were so bad taken straight off ChatGPT plus. Okay,
Aye.
right, here's
The
your
guy
full
doesn't.
definition for Ohm's law. Unlike Sam's definition. Right. Now, oh no. Who can tell me what what this is mathematically? What this means mathematically?
V times I
Oh shit.
equals. Hold on,
Oh,
Oh
oh,
no.
oh,
oh
hold on.
no, oh no.
Wait, let me throw the triangle.
Okay, continue, continue.
Hold on, let me throw the triangle, bro. Hold on.
Continue, continue. It's fine.
Yeah, there we go. There we go. V equals I times R. There we go.
Right. And V over I is equal
Equals
to
R.
R.
And then R, yo, I mean, yeah. And
V
then
over R is
R
equal
is
to
equal
I.
to I. Yeah, there we
Right.
go.
Now this is simple stuff. This the most basic definition of Ohm's law you can give. But when it comes to circuits, we always either working with a series circuit.
Or parallel. Oh,
Yes.
smart, smart.
Uh,
Sam, shut up.
your Sam's catching strays now.
Now Sam's making noise on the thing, bro.
What? I can't even on the chant.
Yeah, bro. On this reacting thing.
Okay. Right. Moving on. Right. So who can tell me what the V total? Okay, wait, let me rewrite that. How do you find the V total in a series circuit? Who can tell me?
I times R, no.
No, you
V
close.
total is V1 plus
Oh,
V2
V
plus
total
V3 or
Yes.
stuff like that. Yeah.
and stuff like that.
And stuff like that. No, well done, Sam. Well done. Well done.
Well done, Sam.
Let me keep quiet. You know,
Yeah, 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 yeah. Do
Yeah,
that.
yeah.
It's
It's
best
best to keep
that
quiet.
way.
Isaiah, you said what? You said I times R. Incom completely wrong.
Incomplete. Sorry. Nice,
Completely
nice,
wrong.
nice.
You guys can
Uh,
shut up now. You guys can shut up now. This
I
is
listen
so.
for, I
It's
listen
so
for, I
quick.
listen.
BBL, Ron start.
okay, the current stays the same no matter what
Zero.
point you measure it, and the resistance total, you just add up the total value of the resistance. Simple stuff. And a parallel circuit?
Isn't it 1 over V?
No, for
Yeah,
V
V
total.
That's
total
resistance.
Oh, my
Yeah?
bad.
equal V total is equal to V1 is equal to V2.
Yeah,
Okay,
ROV, sorry.
right. Then I total.
I is
You add
I1
them.
plus I2 plus I3. If there's
Indeed. And then resistance like cat, said not Sam. 1/R total.
yeah.
Yeah,
Yeah, nah.
see, I was
But if
right.
Is
there's
equal
more
Yeah, well
to.
than,
done, kid. Well done, kid.
if
Thanks,
there's
thanks.
more than,
If you
Okay,
say
Sam.
glory.
if
Why are we
there's
Sam.
telling if
two,
there's more
you
than
say
fam?
R1 times R2.
What?
Well
What?
done, you
If there's two
Ah,
resistors,
shut up, Sam.
listen
Okay,
to
wait.
me.
Yeah,
Listen
Gents,
to
nah.
me.
order.
I kicked this
Write
guy
this
off
in
the
the
call,
test book.
yo.
Foreigner.
All of y'all can check me. Write this in the test book so I
Okay,
can know
wait,
it's wrong.
wait.
You're the
Listen to
only
me,
one getting
Samuel.
it wrong.
You're doing it inefficiently. Do you want to know why?
Why?
Because you can use one formula that applies to
But I mean, I'm not wrong.
resistance value, no matter how many resistors you have. Now you want to go and learn a separate formula just for two
But am I wrong?
resistors.
Am I wrong?
No, you're not wrong, but
Come
you're
on.
also doing it inefficiently.
Yeah, para.
Inefficiency.
That pyro shit of yours is looking very inefficient at this point.
Yo, yo.
Hey,
Now Tiro wants to
Yeah,
start bullying.
Oh, back
yo,
to the
Let's start
ways.
Zelling.
That's insane.
yo,
That's insane.
yo.
You had it coming because you want to act smart here. Okay,
exactly, Sam.
right. Moving on. Do I need to demonstrate to you how this works?
No.
Okay. So then you know how to apply these formulas.
Yes.
I think so. I
Wait,
think
Big
so.
P, can you quickly demonstrate the resistance one for parallel? Real
Oh,
quick.
yeah, yeah, yeah.
Okay, so let's draw a circuit then. Right. So let's say you have three resistors in parallel. Okay, wait, let me just fix my pin quickly. Slight issues with this application.
Sam, Sam.
No.
Yo, bro, you gotta be efficient with it, bro. Come on.
But I'm not wrong. So
Nah, but you gotta be
But you're not
efficient
right
with it.
either.
as long as I'm not wrong, I'm good.
No, but you gotta be efficient with it. I'm telling you now, Sam. Good boy. Gonna listen.
I can't even see you.
Can you see this?
I can barely see it.
Did your phone still not get
Oh,
fixed?
child, see
It's
here.
still not fixed, bro.
Since how
Ah,
many weeks, bro?
For live, trust. By December, I'll have a new phone.
I was fixing this one.
Yeah.
I thought they were fixing this one.
Yeah, I thought so too.
Uh,
At that point,
Now
for
trust we're
some
gonna put
phones, the screen itself is more expensive sometimes to replace than actually buy a new one.
yeah. We're gonna go to MTN this weekend, I hope.
See here.
Okay, right. Let's say this is 5 ohms, this resistor, this is 10 ohms, this resistor, and this is 20 ohms, this resistor. Now, who can tell me what our total resistance is going to look like? Is it going to be more or less than all our resistors added up?
yes.
Do you know
Less.
why?
What?
Do you know why it's going to be like that?
I just know it's because of the formula, bro. Come on.
So, when you look at resistance, electricity will always take the shortest path in a circuit, the path of least resistance. When we look at that, and the reason, right, when we look at that, it's simple. Because now there's multiple pathways, the energy spreads across all three pathways at once. Meaning, no matter how, let's say, tough each resistor is to get through, it will always be less than the most because there's many pathways for electricity to flow through. Think of a highway. Even if you have a very slow highway, as long as there's enough roads, the cars still move along quick enough. If you have too little roads, the cars cannot move through it quick enough. They move through it slower. Okay, so writing this formula, we have three resistors, so we're going to use it like this here. Right. Then we say that's equal to 1 over 5 ohms plus 1 over 10 ohms plus 1 over 20 ohms. And then now what we have to do here is find a common denominator. You have to bring maths back just for this. Right. So now in this case, our LCD is 20 ohms. Hold up, let me just. Oh, that's why I don't have my pen software loaded. Okay, anyways, 20 ohms. So in this case, it's 20. Right. So now you do your simple maths. That's 4 plus 2 plus 1. And then that gives us that's 6 plus 1, 7 over 20. Now, this is not our final resistance because this is 7 over 20 ohms. Well, it's 7 over 20, which is not correct because that's 1 over R total. In order to get R total, we flip it around to make it R total over 1. And that becomes 20 over 7, which is then equal to, let's get a calculator.
People, so through it down with calculations for the year. Now I must go do maths again.
Yes, unfortunately.
Oh,
Ah,
lolo.
no, Joe. Man.
Just
Oh,
right
you see,
there.
Sam, it's your fault actually.
Yo, Sam. If only you were efficient, wouldn't have this problem.
Yeah,
We would
that's true.
be done with it by now. Your Sam
So Isaiah, you're
catches.
the one who asked to do this. How's it my fault?
Oh, so we must all just fail, is what you want
What?
to say. So we must all just fail,
Ngari
basically.
Sam is
You
crazy.
insisted, not me. So it's not my
Are
fault.
you
So
mad?
you
Are
don't
you
want us
mad?
to
Are you
know the
mad?
formula,
Do you
bro.
want us to
Are
speak?
you?
Do you
DP,
want us to speak?
I
Are
DP,
you
never
please
mad?
said
kick
don't
him
learn
from the
it.
Are you
call.
mad? Are you mad?
Your Sam catching strays is wild.
No,
Sam, are
say,
you insane? Are you
Sam,
insane?
leave the call.
How? Are you mad?
Oh, and that's we jump him on
Yo,
Thursday. Last day we jump him.
Real.
yes, yes.
Shans.
Okay, right. Now we're done with. Do you understand this?
Okay.
Yes.
Big P, do you have to always round up to two decimal things?
It will tell you on the start of the paper. If it doesn't say, then two decimals.
Right.
Don't forget the symbols. Right. That's series and parallel circuits in a nutshell. What next? I'm open to suggestions.
Coding,
Uh,
please.
Coding.
Everything coding, please.
Okay, now it's time to teach you guys how to program. A skill that many will never use again.
Yes. I'm dropping
Especially
everything.
you, Sam.
Yeah, specifically you say.
Yeah.
Sam, I think
Okay,
they might be referring to you.
What?
right. Programming is pretty easy once you realize how to do it. Problem is you will not taught right. So here's how I'm going to teach you. Does everyone have a Tinkercad account?
Yes.
If you do, log into it and I'll go through it with you step by step. If you don't, just look at what I'm doing.
Ah,
Oh,
I don't know if that's gonna
try
work.
for seeking.
Let's try and see.
Never
I'll
it.
make a plan. I'll make a plan.
It's can't
Aye,
see it.
aye, aye, aye.
Right. So you see, the problem with programming is it's not a subject you can study. It's similar to maths. You need to practice it. So if you don't understand how to program, there's no point in learning how to code. So we're going to start off with the basics. Even though this is going to take longer, I'm going to start you off with block-based coding.
Excuse me.
Yes.
Uh, how much would this be out of?
That's a good question. Based on like the total thing, it's probably less than 50% of the paper.
Yes.
So does that mean I can sacrifice the coding? Perhaps?
I wouldn't recommend it because some people need marks where they can take it.
But like I don't need to take the subject though. So like can I sacrifice it or nah, that's
Well,
not a bad
so you
idea.
see, let me explain, right? Let's say you want to boost your average, right? This is the subject because it's 1 to 1. It's
Yeah,
1 to 7 basically. So whatever you get, whatever mark you get on that paper, you
yeah.
divide that by 7. That's how much percent it's adding to your term average,
Sure.
which is a bit insane. And because it's
Even
only one paper, that whole exam is that. So if you can get free marks, it's better to do it.
I bet ish.
Okay, now I'm gonna teach you guys 3 years worth of coding in 1 hour. Because did you guys ever do block-based coding?
No.
No,
Well,
that's the
no.
problem.
Well, in
You are
primary school,
mama.
in
Yo.
primary school, we did it.
Yeah, we did do it at some point. I remember.
Okay, but did you go
The
like in
scratch
depth?
count.
Okay, I'm
I
gonna take that
remember.
as a no. Right, starting off with block-based coding, we have blocks, so it's quite simple. You don't have to remember any syntax. But the key point, and even I started on block-based coding, the key point is to get the basics of coding down. Right. The basics are going to be your inputs, your outputs, and your processes. Now, your inputs can be a button, can be a switch, can be an LDR, whatever, potentiometer. Your outputs, think your LEDs, your motors. Your process is the code itself. Now, what the code does is it takes your inputs and it turns it into an output. So, let's wire up a basic circuit here. Let's say you have a let's say you have a push by a switch here, and we're going to connect it to the ground and one of these pins here. So let me rather put it on this side. Okay, you know what? We don't have time, unfortunately, to do this. If I had the whole day to teach you, I would have done block base, but there's no point now. It's too late. It's the last thing. So we're going to move straight to text coding. It's going to make it a bit more difficult. Right. Simple concept of block of getting code syntax. When you do maths, there's a method you need to learn on how to execute a sum. Similar for coding, except you making the method now. You know how in maths they tell you, okay, the area of a circle is pi r squared. Here in programming, they don't tell you anything. You have to make most of the stuff. You are the formula maker. Right. So generally it will give you this to start off with. And what this does is it just turns on this LED, turns on and off this built-in LED here. That's quite simple because you can see if we go line by line, ignoring all these lines here because these are comments. These just give extra information on the code, excuse me. Void setup. Who can tell me what's the difference between void setup and void loop? Sam, considering you can beat Mpilo. Oh, yeah,
Nah, this one I got on log. This one I got on log.
I'm
Okay.
listening. Go for it.
Hold on. So it's tough.
Oh,
So it's tough, ne? Phew, wait,
Yeah,
wait.
no. Acha.
Yo, void loop. Okay, listen,
take
listen,
your
listen,
time.
listen,
Take
listen.
your
I
time.
got it, I got it, I got it.
Take your time. Don't
Yeah,
So,
pressure
yeah.
him, gents.
okay, Hade. What do you say, Big P?
The difference between void setup and void loop.
I bet. So it's tough. Setup runs more than one. Runs once when the Arduino system is turned on. All right,
Mm.
all right,
Hmm.
okay. And then it's also for those study modes and the serial dot begin.
Yeah, and then void loop.
Uh, doesn't that one keep continuously going or whatever? Like,
Yeah.
Yeah.
I bet.
Okay, putting it into terms, simpler terms even. This one runs once. The minute I press start simulation, this will run. And it will only run once. The void loop, this will run as many times. As long as this Arduino board is powered, this void loop will run. As you can see, I can leave it running till tomorrow. As long as the board doesn't get disrupted power or something else doesn't happen, it will continuously run. Simple concept. Why do we now? Pin mode. What pin mode does is, as you can see, digital pins. The thing with digital pins is they're both inputs and output pins. You, as the programmer, have to tell the Arduino what it must be. If you want a pin to be an input, you have to say this pin must be an input or this pin must be an output. Because all digital pins can be either. That's why we call them I/O pins. Do you need something? No. Right. Now, moving this through this, we can see, okay, the pin mode, which is what we say to set a pin. It's going to set the LED built in, which is this one here, this LED, this L light, and it's setting it out as an output. Now, you have to do this, or else the board doesn't know what it's doing with the pin. When we set this to an output, we tell the Arduino, okay, this pin is now an output. You must only output voltage, not take voltage. So then void loop runs multiple times, the parentheses, the curly brackets. Let me make it bigger. Right. Let me make it slightly smaller. Right. What this is it's saying digital write. Who can tell me the difference between digital and analog write? Below.
Please, can you, yo, so may you
Yo,
please ask your question again? I'm focusing on something else.
Yeah.
Ah. Okay, cat,
Ah.
go for it.
yep.
No,
Okay.
wait. Ah, Suga, yo.
So you see, digital. Okay, wait.
Yeah.
Okay. There we go. Digital rights. It's only
Oh no.
hmm,
I can't.
it's only
I,
on or off, right? Am I right, Big P?
Yes.
And then it works with the digital pin on any digital pin.
Yes.
Sam, I'll kill you, son.
Ho, ho, ho,
Ah,
ho.
Anyway, back to what I was saying. Yeah, Sam, I'm reading because I took notes earlier on. Zuck. Anyway, as I was saying, Then the analog, it's not the true analog, it's the whatever that other system is, that he something something.
PWM.
Yeah, there we go.
Would you like to add on to that, Mpilo?
No, I think it's okay.
Oh, isn't
Okay.
focusing.
It's basic enough.
Isn't focusing.
Excuse me. Can I please say something to Samuel Nori real quick?
Okay, go for it.
Hey, Baba Sam, keep testing me, and I'll go find Sebs to come find your papers. You don't have any
What?
papers. Where's your green card? You don't have your green
Ah,
card. I'll call ICE on you. Try, bro.
Ice. That
Good
has
boy,
to be
I'm gonna take you.
xenophobic. That has to be xenophobic.
Yes, it is.
That's
Maybe
the point of it.
can you explain what Kat just said in study terms?
Okay. When the Arduino is set to an output pin, we have two kinds of write. You see this write function here. We have
Mhm.
digital write and analog write. The difference is digital can either be on or off. And when it's on, it will go at max voltage, which in this case is like around 5 volts, I believe. Analog, on the other hand, can go is think of it as a wavy thing. Wavy. It can go from 0 to 5 volts. However, it's not a true analog pin in the sense that the board doesn't actually go to 5 volts. Instead, it uses something called PWM, which is what we call pulse width modulation. What pulse width modulation is simple. So let me switch back to the other thing so you can see what I'm about to draw. Let me just share my whole screen rather. Okay, right. Moving back to this, we're looking at the concept of PWM and analog. So when we say something is analog, okay, well, in this case, we're using American spelling, so analog. Right. So we look at voltages from 0 to 5 volts. As in, it can be any of those voltages. It can be 1, 2, 3, maybe 3.3, maybe 4.2, stuff like that. Simple stuff. Right. That's what analog means. But now, as a microcontroller, as an Arduino board, cannot actually do this. It can't actually range the voltage because it says, okay, I can output 5 volts. It cannot output anything lower than 5 volts, anything more than 5 volts. It's not able to physically do that. That's when the term PWM comes in with the squiggly line. Okay, so generally when we look at the squiggly line, it spins 3, 6, 3, 5, 6, 9, 10, 11. There, those. Right. Now, 3, 6, sorry, 3, 5, 6, 9, and 10, if I'm not mistaken. 9, 10, 11, sorry. Right. 9, 10, 11. Those all have the squiggly lines. Now, not going too in depth of PWM, what this means is it goes on. So let's say we have a graph here, right? Sorry, let me just fix my pin quickly. Okay. Well, let's say this is 0, and when it's on this side, it's 1. And here's this is time. So over time, what PWM does, it goes on, then it goes off, on, off, on, off, on, off, on, off, and so on. And it does this milliseconds apart, something the human eye can't even detect. And this, what this allows is it will take the average of the time on versus the time average time off and calculate the midpoint. So like let's say it's here. This means it's gonna be around 3 volts. So essentially, rapid times. So PWM, you don't need to know what it stands for, but it's rapid timing of that pin. It goes on, off so quickly that the board thinks, okay, now I'm getting 3 volts instead of 5 because it takes averages. Do you understand what I mean? Do you understand the concept of PWM? Does everyone understand? Okay, right. Moving back to this, right. When we look at our code, moving back to the keyboard, what this means is when we say analog, right? Let's change this to analog. Analog, right? Let's change this to analog, right? Now, instead of using high, we're going to use a value from 0 to 5. So let's say 2, and let's say 0 here. And you're going to see it's going to be less bright. Okay, well, that pin doesn't necessarily support that. Let's change it to pin. Let's wire a simple circuit. LED, and who knows what's the key when I connect. Okay, let me just do this quickly. Move this to the other screen. When I connect an LED to anything, what do I have to add with the LED?
A resistor.
Okay. Using simple calculations, can you tell me what ohms it should be? How many ohms for the optimal use LED in this case? Below. You should know this.
Oh, you asking me?
Yes.
Yo. Oh.
What
Uh,
ohms should I set this resistor to?
10 ohms, I guess.
Boom, you blew your light bulb. You blew your
Yo,
LED.
how?
Wait, what's the
Let's see.
voltage, BP?
The voltage is 5
Can you see the
volts.
screen?
So
5 volts.
Okay, let's connect it. Let's connect it straight, right? Let's say we're just gonna connect it from the ground straight to the pin 13, and you're gonna see what happens. Let's say pin 13. We're gonna say pin 13. Okay, well let's switch back to digital right to see the effects. Okay, well this will give me an error because this should be high and this should be low. Right. Looking at the effects of this, what's going on here? It's our light
The
bulb
light
is
bulb
blowing.
blue
Right. So
is below.
you see, right.
I'm on.
Right. So now we're seeing, okay, do you know the concept of amperage and voltage? We all have just gone over the concept of amperage and voltage. So it's saying that we are pulling 53.5 milliamps from the board is providing that many amps. However, for an LED, we can only use 20 milliamps. Now, using the basic formulas I've just taught you, knowing that there's around 5 volts going through here. So there's 5 volts, and currently we are at 53.5 milliamps. But we want to get it down to 20 milliamps. What size resistor are we going to use? What's your formula to calculate ohms? In this case, resistance.
Shucks.
I think you should ask. You should ask Sam. Samuel Masang.
Isn't it voltage over current?
Yes, voltage over current.
I think Sam left, by the
See.
way.
Yes, same left.
Oh,
So it's
oh,
5
I got
volts.
eyes on him. Ah, yes.
Okay. Okay.
Maybe I did.
Peter, go.
Okay, right. Anyways, so we're working with milliamps. How many milliamps in an amp? Mpilo.
Huh? What did you say?
How many
This
milliamps
joke is
in an amp?
cold.
No, I'm finding my robotics notes.
It's not in there,
This
just
is
by the
bro, you're
way.
making
Yo,
noise, yo.
chai.
Just guess, Mfundi.
Times
What's the
what by what?
question?
How
How many
many?
amps are in a milliamp? Or how
I
many?
don't know.
I
Why are you making so much noise? This guy's
I,
panicking, bro.
what's the answer?
It's a
Relax.
thousand.
Oh, calm down, yo.
Pillow,
A
relax.
thousand. Okay, now I know. Now I know. Now I
Yo,
know.
Pillow,
breathe.
relax.
Master of robotics, mind you. So we can't just plug in milliamps because then it's going to give you the incorrect form number. So we have to divide it by 1,000. And dividing this value by 1,000 gives us a very small number of 0.035. Now, putting this into your calculator,
Wait,
0.0,
BP, so is it 1,000 milliamps in an amp?
yes.
Okay.
This gives us 93.4, let's say 67 ohms.
6'7"?
Right. Let's see if our
Masha,
calculations are
shut up.
correct.
Yeah, Masli.
Putting a resistor, and we're going to set it to 93. Let's say 90, let's say 94. There, we got close. We were close. That means there's a slightly more than 5 volts going through here. It's more like 5.1. But as you can see, we brought it down to 20.3 milliamps. Right. Now, back to the coding side of things. This is a simple code that does the following. Okay, let me just set it to 100 ohms rather. Just generally what you do when you spec out a resistor, you go to the nearest whole number. You're never gonna find 94 ohm resistors. It's easier to find 100 ohm resistors. Right. Now, who can tell me the process of this code step by step? Lead me through this code step by step, how I would teach it.
So the one on the screen right now, right?
No, the one on your screen.
Huh?
This guy.
Brother, the
Of
one on
course,
the
the one on
screen.
the
It's here.
screen.
Pillow.
Can you do it, CJ?
I
Yes.
can't even see.
Wait, I
I
can
can't
see it.
even see it. I can't even see it.
My bad.
No,
Wait,
it's okay.
but I can see it.
Okay, so talk us through it.
Okay, so I'm gonna start off by the void loop, right?
Yo, you
Ah,
already.
wow.
No, 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 no,
Nah,
no.
also this guy, yeah.
Yeah, but which one are you talking about?
Yo,
The
wait,
code.
The whole
When I
code,
say
yeah.
code, I mean the whole program.
yo.
Okay. I'll
Start
start.
at line number one. That would be a good start. Line number one.
Just um. So the two dashes and the C++ code and the one under it is just the comments,
Why do we
and
why do
then
we use comments in a program?
it's
In to
to
like explain what's going on.
Yes.
it.
Moving on.
Did he ask you, Isaiah?
Man, shut up, bro. You.
I'm sorry. I'm sorry.
When I ask a question, it's to the general space unless I say someone's name. Mpilo.
Man,
I'm
you're gonna
sorry.
copy off my test
I'm sorry.
anyways, bro. You.
I'm sorry. I'm sorry. I'm sorry.
Carry on.
Okay. Um. So the void setup is basically what you're setting up in the code. It's what you're telling the Arduino about what's going to be controlled. Under it is the parentheses,
Okay,
and
never
then
mind.
under
This will take too long.
sugar.
Right.
Out
The
of
void
hours.
setup and the void loop
See,
are something.
you can't see screen.
Right. Right. The void setup and the void loop, those are something we call functions. And a function is defined like this. Whatever is inside the function will only run if the function is summoned. So Let's go through step by step. So void setup, we know what that does. Runs once when the Arduino board is turned on. These two brackets determine where it starts and ends. Are you clapping below? Why are you clapping?
I tapped the wrong emoji.
Okay,
I was
right,
meant to say a thumbs up.
right. Pin mode. This tells Arduino what pin must be an input, what pin must be an output. I/O pins, input output pins. Saying pin 13, which is this pin. Oh no, this pin here. This pin here, pin 13, and it's saying it must be an output. Moving on. Semicolon after every line. It's a good habit. If you have a code line like this, you put a semicolon after it. It's simple knowledge. Right. Void loop. Inside the void loop, you can see the parentheses here. So this whole function is your void loop. Parentheses, curly brackets, same thing. I'm going to start calling them curly brackets for the sake of simplicity. Right. Digital write. Setting digital write turns a pin on or off. Analog pin does the same thing, on and off, but with the added functionality of PWM. We generally only use digital write. It's setting pin 13 and it's saying it must be high. That's the whole function. This is going to set this LED on, or whatever is connected to pin 13 on. Delay. It's in the name. It delays it for however many milliseconds. So that's how many milliseconds in a second, guys?
1,000.
Right. Thank you.
1,000.
1,000. 1,000.
A thousand.
Yeah, I
Wait,
believe.
wait.
Okay. Right. Who can tell me what the next two lines of code does from line 12 to 13?
So line 12, it basically it turns off the LED, and
Why?
then
Wait. No. No.
the
No. 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 Stop. When you say LED, I could be talking about the L LED. When you're talking about LED, I could be talking about the transfer and the receiver LEDs. What
It turns
oh
pin?
off pin
You have to
13,
say
right?
pin 13,
yes,
Yes, the relay.
cut off power to pin 13.
right? And then the next line?
It
It
delays for a
basically
second.
tells
Yes, right. Now, who can tell me I want this light to stay on? What must I do? Anyone but below.
Uh,
What would I remove?
Well, you lagged. Can you please repeat?
Wouldn't
If
you
I want
remove
the
the
LED to stay on all the time, what must I do?
wouldn't you remove the
delay.
line 12?
Yes, line 12. So let's remove it. By commenting it out, the board doesn't ignores it.
Oh wow. You see an answer, but I can't see it.
Yeah, I understand. It's fine. It's calm. Right, there, it's staying on. Would you look at that? Simple stuff. Moving on to actual code now. Let's say, okay, right. Most of us here play games. So I'm gonna use a bit of game terminology here. Let's say I want a car simulation. Now that we must know the X, the Y, and the Z coordinates as with decimals. You must be able to define each variable and assign any value to it. Let's say, and assign the following coordinates. Let's say 0, 0, 1. Assign the following values to each variable respectively. Who can do this? Generally, when we're looking at this, you can either assign it the variable here, b, So let's say you only want to access, let's say you want to access the variable everywhere. You put it here on line one to whatever. If you want to only access it in void setup, that's where you declare variables. You can put it in there. So for now, let me just check my previous code quickly and see which one Mr. Guy prefers. Let's check this one here. Okay, we declare it in the setup. Okay, right. Now, anyone besides Mpilo, guide me through this. You guys know how to declare variables and assign it values.
No.
Okay, then let me teach you.
No.
Let's get rid of this and put this here. Right. When we declare a variable, what's the first thing? We must declare what type of variable do we want. If we want a variable with decimals, we use a type called a float. Okay, well, I spelled that wrong. Float. And a float is short for floating point numbers, which include decimals. So a float. And we want to call it x underscore coordinate. Coordinate. Let's say x codes. Who can tell me why I didn't put a space there? Just for fun. Okay, generally when you assign a variable, it's better to put an underscore and not a space. Because generally a space the compiler, the Arduino doesn't like it either. It's fine, but it makes it less legible. Right. So we're gonna this defines it. This creates the variable on on the Arduino memory. And it says, okay, label this piece of data float coordinates. Well, it's x coordinates, and the type of variable it is a float. Then we want to set the variable. We want to give it a value because think of it like this here. We have your computer memory here, or let's say the Arduino memory here. And all it is a bunch of boxes with ones or zeros. And it's saying set this to x code. Let's just say x code, and let's say it has this values here. It's saying set this memory box to x coordinate, make it a float type. Now we are able to directly access the computer's memory and change these values. Moving back to this, this defines it. This names that box because all your memory in Arduino, you have a whole bunch of boxes. All you have to do is assign a name and a type to it. So in this case, we've already assigned the type and the name. We call it float coordinates, and the we give it the type float, and we're saying x coordinates is our name. Then we want to set it to 0. So it's that simple. But generally with float values, you put it point 0. Then who can tell me how to do it for y, the y value?
It's still a float. I still make it float.
All of them are floats because
Okay,
we want
so
to be
we
able to
say
handle decimals,
float
right?
y underscore codes semicolon.
Right? That's to define
Then
it.
yeah, then we say y underscore codes equals to 0, 0.0 semicolon.
Yeah, right. You must make sure that your spelling is correct. Again, lastly, for the X1, the Z1, it's basically the same thing.
So wait, Big P, do you put point zero for all of them, even one?
Yeah, so even in this case, it's 1.0. Because when we work with float numbers and you don't have a decimal already, you just add that point 0. Yes.
So
BP, are you gonna continue the lesson after this thing ends?
Okay, let me send out the new link quickly.
wait, BP, before you do that, um, what was I gonna say now? Do you have to put point zero for like the other variables also, or just floats?
So only floats So out of the ones we know, we only doing floats. So only floats will have that.
Right. So in the test, this
Secret.
is only variable float.
So
No,
it will
there's
be
there's
float, integers, or booleans. I'll go over through all types.
Right.
Okay, let me send the new link. Chat. There's the new link. Turn off my camera and I'll start sharing. Okay, everyone leave this current meeting and join the other one. Okay, let me just make sure everyone gets it. Okay, right. I'm leaving this set. Okay, I'm leaving this on
Simply,
here.
so if we understood everything so far, would you say the rest is like easy?
Yeah, because I'm just gonna go over the other variable types and do a
wait.
bit of other coding, and then
Ravi,
we
am I
try.
right when I say Boolean is true and false or true or false?
Yes, but just remember when you're defining it, it's not boolean. It's just bool.
It's just bool.
B double O
So,
L.
so
Okay.
would I say bool?
Okay, let's expand on this program here. Right, and we want to know whether. So we want to know if the car. We want to know whether the car is moving or not. Then we have to include a boolean variable, and we want to say start moving. So we're going to start the car, and we're going to say the car is moving. So let's create a boolean variable. For boolean, it's either true or false, and it gets the type bool, B-O-O-L. Right, and we're going to say car is moving. Excuse me, spelling. Then it's slightly different from what been doing so far. When we work with such with a boolean data type for a bool, it's either 1 or 0. It's either on or off. It's either true or false. False. Right. So then when we say this here, we need to say car is moving. And what numerical value are we giving it here? We want the car moving. Will it be 1 or 0?
One.
1. Right. And if we run this, there'll be no um oh sorry. You know what's happening here? You can't have a dash. The dash is throwing everything off there. That's why. Should be that. Oh, and my spelling. Yeah, my spelling. That's why when you're naming variables, you have to make sure the names are correct. What? Oh, I copy pasted. That's why. It must be Z. Yeah. Okay, excuse all my errors there in my coding, but that was silly mistakes. But otherwise, it's working perfectly fine, the program. So now we have the following four variables. We've defined the x, y, and z coordinates, and we now have a variable to check whether the car is moving or not. Simple stuff. Does everyone understand these two variable types? Right. Integer is very similar to float, except integer now. The way you declare it is, let's say we want an integer for the, let's say, the tire size of the car, something random like that. Right. So now we need an int. We declare an integer with a class int type, and we're going to call it tire underscore size. Right, and we're going to say tire size is equal to, let's say, 20. And that's how you declare an integer. That's declaring variables. Quite simple stuff. Let me just get the breakdown to see what else there is here. Okay, so do we understand how to do declare and assign value variables?
Yes.
Right. So I've gone through that. I'm gonna do this more complex stuff now. Do you understand the difference between setup and loop methods? Right. I'm gonna list everything and you need to tell me what I haven't gone over yet. So I know variable declaration, I'm good. Assigning values to variables, we did. We're gonna write, okay, we're gonna write code now. Difference between setup and loop, we done. Difference between digital and analog, fine. And I'll go over the robotic stuff now. Electrical component symbols, that you just have to study. Series and parallel circuits, I just did. And examples of where robots are used. Okay, it's just a bit left of the coding and the actual robotics part, so we can get through this. Right. Okay, sorry about that. Right. So looking at this, you would look at this, right? Now we're going to do simple calculations using this. So let's just get rid of all of this code we just typed out. Right. Simple. Right. Now let's say we have how much let's say we have the value of income. And let's say we have a few taxes to pay off. Right. So the income, let's say we make 10,000 Rand per month. And let's say we have to pay 14% tax. Right. What's going on here? And we need to print all of this. We're gonna print all of this. Good night. Right. We're gonna print all of this to the serial monitor. Right. Simple concept. We're gonna always start off with serial.begin. Think of this as whenever you start a call, you have to press the accept button. This is the sign to tell the Arduino, press that accept button on the core. That is will start the communication. Now, we want to declare float variables in this case because with a percentage tax, most of the time you're going to, in this case, and let's say then he has 10,000 Rand, he's going to get a bonus of, let's say, 500 Rand, and he has 14% tax to pay. Right. So we're going to declare a variable, a float, and we're going to call it the income. Now, generally, you don't have to skip lines when you're writing it down, it just makes it look neater. Income is going to equal to your 10,000, right? Then we have we have the bonus. Let's call it a float bonus. The bonus is equal to 500 Rand. Exclude the Rand sign. And make sure you put semicolons when you're writing it down. Right. Then we need to include the tax. And let's call this an int called tax. Let's say tax is equal to 14. over 100. Okay, that won't work. Right. Let's just say tax is equal to 14, the percentage wise. And we need to print all of this to serial monitor now. So first, what we're going to do is we're going to create one more variable. Let's call it a float and call it final and call this updated income. Now, updated income will update after every step. So this is updated income. Now, in order to set what updated income is, you're going to take obviously the 10,000 rand plus the 500 rand, the bonus. And if we run this to make sure that there's no errors, yes.
Big B, didn't you say that when you do a float, you're supposed to put like point 0 at the
Okay,
end
so
of
you
the line?
see here, there is no, we're defining it with numbers. When we do an operation, it will automatically do that for you.
Oh, right.
You understand that?
Yeah. So it's only like when we're not given something.
So like with floats and that, generally it's best to put the zero. Thanks for pointing that out. But because we're doing operations with them, it doesn't matter.
All right.
Okay, and let's print out all these values. So we want serial.print, and we're going to say print the income. Right. We're going to go to the next line, and now let me explain how this works. See, who can tell me the difference between serial.print and serial.println? Right. Difference is serial print prints it to the console and does nothing else. Serial print ln, on the other hand, what it does is it prints it to the console and then goes to the next line. Simple stuff. So when I do this, we're going to see what we have so far. It's a good thing to always go back to your code and make sure it works. Right, we're going to get this value, which is correct. Right. Then we want to print out the bonus. What's our bonus this year? Make sure that the Tomazo is there. Right. And this is going to print out the income and the bonus. Then we want to do it one last time to print out the updated income. Right. Does everyone understand the calculations and what I've done so far?
Yes.
Right. So as you can see, it printed out the income, printed out the bonus, and now our updated income is 10,500 rand. Simple stuff. Right. Moving on. Now we're getting tax of 14%. So now, who's very good at maths here?
See here.
Mm.
Okay. Can you tell me how we calculate how much are we paying to the government in taxes?
We're paying the government 1,400 rand.
Okay, I understand you know that. But walk me through the formulas.
So like in maths or in code.
In, let's say maths, I'll translate it to code.
Okay, so wouldn't it be 14% times 1,000?
Okay, right. Here's the thing, right? What is that going to give us? That's going to give us how much tax we're paying to the government. That's correct. So let's So we already have a text percentage variable. So instead, what I'm going to do is I'm going to create a new variable and call it text to government. So let's create a float, call it text to government. Let's say text to G. Text, or it should be text, yeah, text is going to equal, what variables are we using though? We're going to use our final income, which is the updated income, and we're going to say times by the text, which is the 14%. And what value is this going to give us? It's going to give us 1,400. Right. So let's print all of this out. So we're going to say serial dot print. We're going to say text. Let's say text to pay. And our text to pay is going to be whatever number this equation is going to give us. Now, note, when you're doing coding, you never use a multiplication sign, you use the star. Because with computers see the multiplication sign as a normal X. So use the star. So text G. Right. This is going to give us, okay, well, something's not right there. Because we times it by text, we didn't divide it by 100. We have to divide it by 100 because that's percentage wise. 1,470 rands in text. Now, that's how much we're paying to the government. And we want to work out our final income. So, what we're going to do here, right, what we're going to do here is the final income. We're going to use the updated income is equal to whatever tax we're paying minus the updated income. So, the updated income is currently set to 10,500 rands. And we want to subtract the updated income by, let's see, by whatever tax we're paying here, tax to G. In this case, we're subtracting it here. Note something, in maths this makes no sense. In programming, what's happening here is we're taking this variable and we're saying when we set a variable, it doesn't matter what the previous value was. We don't take that into consideration. We're going to pull the value 10,500 minus the tax to G. And whatever the number on the right hand side is equal to, that's what the updated income is set to. So in this case, we get the number of, didn't print that to the serial. Right. Let's clear this. And for the final time, okay, for the final time, we will see that our income won 10,000 rand, our bonus 500 rand. Adding those two together gives us 10,500 rand. We pay 1,470 in tax, and our final income will be 9,030 rands. Does everyone understand this?
Yes.
Yes.
Wait,
Yeah.
Pravio, so
Himpi, can you
if
please send pictures of this
I
code?
think so.
Right.
in Pravio, every time we declare new variables, we have to add a comment.
No, I did that to make it more legible to you guys.
Okay, so you don't have to add comments.
You don't have to, unless it says add comments, don't add comments. Comments are just for future purposes because you're only going to ever look at this code once. There's no need.
Right.
Yeah, I sent the code on the respective groups.
And then for serial print and serial dot print ln, what we put in there is what's being arced, right? So then we would do the variables and then do it.
No, 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 no. Let me explain, right? When I put quotation marks here, whatever I whatever I write here gets printed exactly how it is. But if I don't and just put a variable name, that variable's value, in this case, income's value, gets printed to the serial.
Oh, okay.
Understand that?
So, in essence, serial dot print where you put the quotation marks has to be different from the actual variable.
Yes. There is a way
Okay.
to put it on one line, but I'm not going to teach you guys that. There's no need
All
to
right.
learn that.
Right.
Right. I've covered almost everything except symbols. Examples of robotics are used and disadvantages of robots. Would you
Wait.
like me to
So,
go through that?
please.
Okay. Is there any other questions with this stuff here, this coding?
Mm.
I wanted to ask what the area of a circle, I think. Is that
Yes.
what we have to know?
Yes.
Uh, so how would we do that? Like the same like this, basically.
Similar format, except in performing, however, instead of performing like six different calculations, you're doing it once and you're printing the
Oh.
results.
But then when you declaring, I think you would declare like area or
The
something.
radius and the area of the circle, and then you set the area of the circle to radius times pi. In
Oh.
this case,
So what
3.14159.
variable would you use?
A float. Use floats.
Right.
Any other questions before I move on from the coding? So if I give you guys a code, will you be able to program on a basic level?
Yeah.
Yes.
Hmm, hmm, hmm.
I'm actually see you struggling.
Rokangatela,
Ah,
rokangatela.
let's do it, man.
Uh,
Ganda kana.
I'm dropping IT first day, bro. No worries.
Ah,
it
we
is
know, we
easy,
know.
man. Let me tell you something. IT is easier than cat if you can program. If you want me to, I can teach you how to program properly. Then IT will be easier than cat.
Oh wow.
Do you
Uh,
understand why? Because in cat, it's a lot of using the actual applications. In IT, you're just typing and typing and typing.
Yeah, I see what you're putting down.
No, give it 2 weeks, bro. Then it's chat.
I must we know.
I give it the first day, I see this guy's moving to cat.
This
I don't worry, my I believe in you.
I actually don't even buy the textbooks, dog.
Okay, that's insane.
Is it though?
Yeah, is it really worth it? Here's the question, because you're gonna spend however much on textbooks.
Yeah, okay. Never mind, I don't believe you.
shucks.
yo,
You'll be strong, don't worry.
Hmm, hmm.
Yeah, I don't think so.
Okay, right. Do I really need to go over the symbols, or is that something you can just study on your own?
We can just study the symbols.
Examples, you just use your brains. You just have to like think of it more in the real world. Disadvantages, they take our jobs, they consume resources, simple stuff like that. So anything else anyone wants me to go over? Because
Wait,
after this, I'm yeah.
does anyone know how much the test is out of?
No, sir.